Welcome back. This is the second presentation of this morning of Wednesday, and the speaker is Mohamed Alji from the National School of Applied Sciences in Kentira, Morocco. So, Mohamed, whenever you are ready, you can start.
Thank you. So I will be presenting a file/slack handling tool. It is a work in progress. So my name is Alji Mohamed, and I'm from the National School of Applied Science from Kentira, Morocco. We organized the presentation as follows. We will first start by an introduction. We'll put you in context, and we will explain the motivation behind the making of such tool. We'll then move to explain some involved concepts. From there, we will depict the method we had adopted. The results are a proof of concept tool, which is named file/slack handling tool. And by the end, I will conclude by some work we are working right now, current future work. So the context is as follows. We are mainly focusing on computer forensic investigation related topics. The input of our tool comes from a cold acquisition, meaning we have at our disposal a computer which is unplugged from unplugged device. We extract from it the disk drive. From the disk drive, we generate or we image copy bit by bit the original disk drive to create a forensic disk image file. The disk image file is nothing more than a representation of volumes and NTFS formatted disk which contains files and their metadata. So what is the motivation behind the making of such tools? Well, first thing, let's consider the following scenario. A suspect deletes a secret file from an USB thumb, which is NTFS formatted. You know, even if the file is deleted, it can still be recoverable. However, it might get squashed later by another file. Even though it is squashed by another file at the same location on the disk drive, there is a part that is still recoverable, named file/slack. And it is due to the file system design, the NTFS file system design. So when NTFS file system allocates space for a file, it allocates it based on a logical unit, meaning the real file size is not necessarily the size which is on the disk drive. It allocates based on a certain number of cluster, which is the logical unit. From there, we can understand that there is a misalignment that is generated at the end of the file between the real file size and the number of the logical units allocated for that file on the disk drive. We have discovered that there is a certain forensic value of this file/slack because it might contain unsquashed data from previously located file there. So what are the concepts involved in the file/slack tool? Consider two things. The sector, which is the smallest physical units on the disk drive, which is kind of hard-coded. Most of the time is 512 bytes. However, when Microsoft operating system address for reading or writing storage, it uses the logical unit cluster, which most of the time for NTFS formatted partition is 4 kilobytes. Okay? Knowing this, when a user creates a file, the NTFS file system does not allocate its real file size. However, it allocates a certain number of clusters. From there, we can get the following equation. The real file size is most of the time less or equal than a certain number of allocated cluster multiplied by the cluster size. At the end of this file, we get the file/slack space. I have a representation here, which it's a simplified one. This is not a realistic one. However, it explains a couple things. The texture, you can see it as a unit, as a physical unit in yellow. Okay, the cluster is 4 sectors. Okay, and the file size in this case is 2 clusters and a little bit more. Take it for example as 4,400 bytes. In this case, the NTFS, the operating system, will allocate 3 clusters rather than 2 clusters and a sector. As you can see in the representation, the real file size is different from the allocated space, which is 3 clusters. From there, we get that there is a file slack that is generated at the end. The file slack is 2 things. There is the red, which is run slack, which is nothing more than just padding. And most of the time, it's just zeros. And there is the disk slack. The disk slack in green, you can see it there. Disk slack in this case is 3 sectors. The disk slack is what has been there before and was unsquashed before. Okay. From there, we get a forensic value. The recoverable disk slack has a certain value because it's contained data from a previously located there file. So what is the method we follow in order to extract those file slack? We initially have at our disposal a disk image file. We go through recursively from the root directory for each regular file. Each regular file, we walk through all its attributes to locate the last interval of cluster. From there, we locate the last cluster. And from the last cluster, we can distinguish the row slack, which is mostly just padding, and the disk slack of interest. Okay? In order to ensure that this is not corrupt, that the extracted file slack is not corrupt, we hash the extracted files using MD5 and SHA-1 algorithms. So the results are the implementation of the file slack handling tool. It does what follow. It can extract file slacks from a raw disk image file or expert witness forensic format file. Okay, it can hash the extracted file using MD5 and SHA-1. It provides the user with a detailed reports, for instance, the hashes, the partition, the parent directories, the file name of the slack. And the tool is command line oriented, and it is right now available as a pre-release on Python package index. You can easily install it using pipe install slack handler. The tool is a proof of concept, and it is written entirely in Python 3. It is based on a module named PyTesca, which is nothing more than Python binding for the sleuthkit library. The sleuthkit is a very known tool and collection of tools, utilities, which allow the extraction of data from disk images and storage. You know. While we were working on doing some research, we find a very interesting script named by Socrates Vidro, and we based our work on it so that we can make this. The source code is freely available at GitHub at the address shown on the slide, and it's under the GPL2 license. Here is an example of running of the tool. Slack handler take this image file as input, named, for instance, USB ntfs.dd, and the type of this image is raw, can be expert witness forensic format. It can dump to slacks dir all file slacks for each regular file found within the disk image file, and generate a report in CSV format as shown on the output part. The output part show report CSV, which is like this one. For instance, there is a slack file name, slack size, the partition, and other details. The slacks dir will contain the extracted file slacks in raw format. To conclude, the scope of this tool will remain the extraction of file slack and all its related details. For now, it supports raw disk and expert witness forensic format, but we intend to add support for advanced forensic formats. We also would like to optimize the way to locate file slack, not just the same way it's doing this right now. We'd like to optimize it, and we intend to assess it to other tools we found. For instance, the export feature of WinHex. We are also working right now for a script written in Bash scripts to simulate the user behaviors such as moving, removing, deleting, renaming, and copying files, and the script will generate also disk images fitting it. The aim is to validate, to create create test images for validation. And maybe at the end, we will make available forensic copies of FileSlack, because there is nothing like this available for the forensic community, digital forensic community. Thank you for your attention. And I would like to tell you that the tool and the code source are available at GitHub SIM Forensic Slack Handler. Thank you.
Thank you, Alji. That's really fascinating work. There are a few questions in the chat. The first one, they say, thank you for the presentation. And how do you plan to extend your existing work, and what new features might be included?
Well, the new features that we intend to make available is extraction of distinguishing between the RAM disk and the disk, the RAM file slack parts and the disk file slack parts. We'd like to make available the option for a user to export either both of them as file slack or distinguish between them. And the second part is that we intend to extensively test the tool in order to ensure it does what it's meant to do. Because the problem with NTFS is that the files are most of the time not located at the same location on the disk drive. They are fragmented and they are everywhere. They are everywhere on the disk drive, and you have to go walk through all attributes to find the last location. Okay, so we intend to test as maximum as possible those cases. We are also right now working on the case where the file slack, there is nothing like file slack, meaning it is a scarce case where the real file size is equal to a multiple of cluster size. That's it.
Okay, great. So you've been talking about using forensic evidence or images of hard drives. Do you think that you could do the same live in a hard drive? For instance, I could use software to verify if I have any leftovers from previous files in my hard drive.
We haven't think about this, but I think technically it's possible. We can investigate this route,
I'm asking that
for now, it's a cold acquisition. We are basically taking this image as an input, but for a live system, it's will be a little bit different.
Yeah, mentioning that because nowadays maybe a lot of companies, they start using cloud services where the resources are dynamically allocated. So sometimes maybe you are reusing some disk space that some other user was using before. Yes. As well, that some companies, they have some thin clients where the same hardware is reused. Do you think that could possibly open a window for more, to finding more Slack?
Slack, yes. If ever we are able to get a bit by bit copy image of the cloud disk, cloud storage, it can process it easily. It depends. On the other hand, it will depend on the format. If it's raw, it can process it right now. But if it's not, we are working right now on the advanced forensic format. But it's a very interesting point. Haven't thought about this. We can make it possible. We can does we can work on an example, to pull from cloud storage disk image and work on it. It's feasible,
Okay, so what would you recommend to people to avoid leaking information? Is it just wiping the hard drives?
Well, yeah, they have to wipe it all the time. Well, there is a lot of methods to wipe the hard drive, and they have to ensure their personal data are not recoverable anytime. I think there is another question.
Yeah, so they are asking you if you are planning any analysis where you compare your tool with existing other forensic tools.
Yes, we intend to assess it. For now, I have let's say 3 tools: WinHex, Autopsy, and some couple scripts online using PyTesca. We intend to compare the output of our method to there. So we intend really to assess the results of our output to their results. However, there is a different thing, because WinHex, for instance, it dumps all the file flag to the same file. Files Autopsy dump it for each file. There is a lot of things to be done before being able to make an assessment.
So I think that there is a clear takeaway from your presentation, that don't let your USB drive to your colleagues, because maybe they will find your secrets. Okay, I think that we don't have time for more questions. Thank you, Alji. It's been a fascinating presentation.
You're welcome.